Hello, everybody. I'd like to welcome you all to today's webinar with our Eastman people, Rebecca Glaspie and Randy Waymeyer, both chemical engineers. Randy is a chemical engineer who led the life cycle assessment team at Eastman and is working on integration of new chemical recycling technologies. We'll be hearing from him first. And then we'll be hearing from Rebecca, who's a senior chemical engineer at Eastman with 12 years of experience in manufacturing, life cycle assessment, innovation, and biomaterials. Valentino Prado, our senior sustainability analyst at EarthShift Global, who brings extensive experience in developing decision analysis tools for life cycle assessments in LCA, and has hands-on experience in SROI, the Sustainable Return on Investment, will also be here on call should you have any questions. And as usual, I ask that you send your questions to Randy, Rebecca, or Valentina via the chat feature to me privately, Holly Harris, and at the end of their presentation, I'll ask your questions for you and we'll hear their answers. So without further ado, welcome both Randy and Rebecca.
Well, thank you so much, Holly. And I have to say thank you as well for the opportunity to come present at one of these brown bag webinars and share some of what our thinking is and what we've been working on here in our little LCA community. So today, on the next slide, we are going to be talking about an energy apportionment approach, and we'll get into a lot of the details about what that means and why we think that it's an important tool in the toolbox of LCA, and how we can use that hopefully as a jumping off point to accelerate investment in low carbon technology. So to start us off, I'd like to talk a little bit about Eastman, the sustainability story at Eastman, our life cycle assessment team, and some of the barriers that are kind of inherent within the chemicals industry. And then we'll get into more of the details of the apportionment approach and discuss a little bit at the end about the value that we think that this is generating. So who is Eastman? Eastman is a specialty materials company that makes a bunch of different chemicals going into applications that are really, really diverse and interesting. We'll make paints and coatings, additives for tires. We make a lot of different specialty polymers and plastics. You might be familiar with the clear, hard, BPA-free plastic that's in an Nalgene or a Camelback water bottle. And a myriad of other products. I could list them for days because Eastman is a relatively large company of between 14,000 and 15,000 employees operating in more than 100 countries. So being a large company like this, we definitely need to keep sustainability on the forefront as we approach our strategy in terms of the company that we want to be. And a kind of guiding principle here is that we want to generate more value in the products that we sell than the burden of the resources that we're consuming. We really want to enhance people's quality of life by focusing doing good in the world, making sure that we're paying attention to good corporate social governance and all those sorts of things. Simultaneously, we want to make sure that we're going in a direction looking for applications that steer our portfolio in a sustainable direction, and all the while making sure that we're getting the most bang for our buck in terms of producing efficiently and with the least burden associated with our production. So how do we measure that? Well, that's why we've got this LCA team. There are a lot of people actually working behind the scenes that are different from our team, but we kind of see ourselves as a bridge between some of the manufacturing arms, the business, and sustainability. So we can use this data-driven approach to see the impact that we're having on different products, and we can leverage that in both innovation products. We can look at projects that are just coming off the drawing board and going to be in the next horizon of projects. We can look at refining and giving recommendations for more traditional products and processes within our organization. And we'd like to use this to build up kind of a network of discussion where we can use the carbon accounting that life cycle assessment is so good at to drive better informed decisions. So we can create this value in a number of different ways, and on the next slide, it kind of summarizes the, how we like to value or how we like to leverage LCA in terms of creating value for the company. So we can do that by setting a strategy, figuring out how possible it is, what sorts of levers are available to pull when you're looking at this large integrated global organization. You can identify hotspots throughout our operations and also the supply chain. And then that can drive innovation where we're looking at new product development, different processes, breakthrough technologies, figure out where we need to invest and how to design effectively for the environment. Then when we have this data, when we can rely on that, it makes it a very powerful tool to educate both internally and externally kind of these choices and the impacts that we're having, right? And this is great to drive employee engagement. We can show the benefit of and the tangible effects that some different projects and processes might have. And it's all in the service of building up a sustainability story for Eastman as a whole and also the different products that we make, so we can go then externally and engage in some pretty fun co-innovation with different stakeholders and customers around the world. And the reason why we can do all of this important work is because there's a lot that we need to do. The chemicals industry is very large, accounting for at least 15% of the direct carbon emissions of the world, including lots of indirect emissions too that we don't necessarily think about. And in order to meet all of these global commitments, we need to engage in pretty dramatic cuts to our emissions and rethinking of how we're looking at providing these different services that people need. So it feels like a very important and impactful area to work because there's so much potential and so much need as well. And the challenges are pretty big because this is a large, we're dealing with large facilities that have long investment cycles. When you build a chemical plant, you want that chemical plant to last as long as possible. The idea is that you would have you don't want to be rebuilding and restarting from scratch all the time. And so these facilities need to be forward-thinking in the services that they provide. And many of the processes, in order to drive that resource productivity and have the best bang for your buck, you're using large assets producing commodity goods that other chemical companies are producing too. What that means is that it may provide a challenge for change because you're competing based on price with a whole bunch of other companies. So the idea of investing in breakthrough technologies when it would raise the price of a good can be a hard sell. And as a chemical company, we're often doing business-to-business sales of our chemicals, and so there's a lag in pressure. If the consumers are putting pressure directly on the brand owners, there's a layer of insulation before you get back up to these formulators and basic material producers. So the business needs to be made more aware of kind of the different impacts here so that instead of just focusing on the product performance and reliability, you can really bring the manufacturing impact into account. So on the next slide, we're thinking that this shift in public perception to value sustainability and environmental footprints more is a way to get away from some of these barriers and value up the chemicals that we're producing so that they can compete on the quality, not necessarily just a quantity throughput type of idea. And one of the ways to do this is to build environmental performance into that value proposition as a way of differentiating these different chemicals and providing a business case for change internally. So one of the biggest levers that we have under our control is the power that we produce and the power that we consume. So how do we internalize that idea that has been, people may take the energy that they use for granted. So what we're trying to propose here is a way of distinguishing between energy that's coming from different sources and then tying that energy from different sources to specific products. So I'd like to turn it over to Rebecca, who will go through some of the details and define sort of what we mean by this energy apportionment approach for energy accounting. So Rebecca, go ahead.
Thank you, Randy. This is the journal article that has been available online for a little while now, but was published in the June issue of the Journal of Cleaner Production. And thank you, Valentina, for all your hard work as well on this article. So I'm going to talk through an illustrative case, but it was very similar to the thought process that went on at Eastman. We assumed in the article that we had $30 million to spend on an energy investment at a really large chemical facility. And this just happens to be a picture of one of our powerhouses, so it's not too far off. The $30 million we used for either do a solar project or produce energy by retrofitting a coal gas power plant to a natural gas power plant. And we were really wanting to think through what's the best use of the capital and how will the capital investment impact the products, and could the impact be greater for the specialty product if we thought about things differently. In this hypothetical company, we assumed that there was these specialty products which were really energy intensive, 4 times more energy to produce these specialty products than a commodity product. It's been fully optimized and it's all about producing pounds quickly. So these specialty, more designer products were assumed to be about 20% of the portfolio, and the business value for these products was on quality and not quantity, just like Randy had talked about earlier. Where the 80% of the company was all about making pounds. They were commodity products. They make the same thing every day, and they just try to cut out as much cost as possible. So this is a picture of that view, that business. So we'd assume that they were shared the same powerhouses to make both products, and everything was on coal in our assumption. The 80% of the business that was making commodity products was using coal power energy, and the specialty business, again, was using coal power energy. But if we're going to spend this $30 million of capital, which was either going to be solar or natural gas, you would typically spread that investment, the energy produced from that investment, over the whole site because they're sharing the same power grid and steam usages or steam headers. So when you do this, the impact is diluted across all the products. So we proposed this apportionment approach, which would subdivide the energy and put it all on the specialty products. And you can never do that perfectly. So every year you'd have to make adjustments because you wouldn't do double counting, you'd have to make adjustments. So if the specialty business doesn't use all of their power that they invested in, the conventional business would get some benefit from that power investment. Or the specialty business, if it uses more energy than is produced by this new installed green energy upgrade, it would have to use some of the conventional power. All right, so when we came up with this, we thought we have to have some rules. Got to put some rules in place, and some of them are pretty typical LCA rules. So you don't want to double count, right? We never want to double count so if you're using one allocation method somewhere, you can't use a different one at a different place on the same product family or in the same system. So that was number 1 rule. The second rule is that we needed to assign the benefits and the costs to the business unit. There had to be a financial tie to those benefits. And then we also decided that you shouldn't be able to just willy-nilly change who's getting what power like year to year. So as long as the investments are still there, so the assets for those specialty products or the assets for that power are still in use, they shouldn't change. And then you need to maintain proper documentation to guarantee transparency and consistency, and ideally it'd be something that's auditable. All right, so this graph can easily get you confused. I've been confused by it before even. So we're going to start by just looking at the total height of the bars. So on the left-hand graph, you can see that before you do any energy investment, you're emitting 612 K-tons of CO2 equivalents per year on this hypothetical business. And then if you choose the solar investment, you would reduce those environmental impacts to 578 K-tons of CO2 equivalents per year. And then if you did the natural gas retrofit of one of the coal-powered boilers, your benefit is larger, and you're now emitting 422 K-tons of CO2 equivalents per year. So that's the graph on the left. The green bars are the specialty business portion of those CO2 impacts. So depending on whether you use the subdivided approach or a blended approach, you can change how much of that environmental impact is associated with the specialty products versus the conventional or more commodity products. So you can see that the subdivision approach in both cases benefited those specialty products more under a total emissions for those specialty products, but the total emissions for the site didn't change. Now going over to cost, in this specific instance when we used, because of the public literature that we used to build these cases, the cost for solar was actually higher than the coal-powered power plant that we used for this case. All of it was from literature, and you can read our article to find out where those sources are. I don't have them on the top of my head. But the solar installation costs a little bit more per year to operate. And so those costs associated with operating those solar panels would then go to the subdivided business, or the specialty businesses, so that in the subdivided approach. So the specialty businesses would spend a little bit more for their energy. However, with the natural gas in those publicly available literature sources actually costs less for operating a natural gas power plant over a coal power plant, because natural gas prices at the time that we did this article were much lower. Those specialty businesses actually end up paying slightly less for their energy. The thing I want you to take from this is that no matter what, whether you do subdivided or blended approach, the total costs and the total environmental impact didn't change for the company. It just changed where they were associated. And also with the subdivided approach, it allowed the green energy costs to be concentrated on the specialty businesses that both valued the improvements and actually had higher margins and were able to afford the investment. All right, so the specialty business area on the left had a lot of movement in this graph. So this is actually going up the chart. That's greater climate change impact savings. So the higher that things are on the x-axis, the better, the y-axis, I mean, the better they are for that specific product. And as you can see, there's lots of movement in that direction for the specialty business area, where the conventional business, everything stayed pretty close to the same location. So what you're seeing is that with natural gas subdivision approach, there's a large benefit from the subdivision versus the blended approach, but both of them are much better than business as usual. And with the solar, the subdivision approach made it actually impactful. So with a 21% reduction in the cradle to gate impacts for those products, with a 28% cradle to gate impact change. Where the changes on the conventional businesses or the commodity businesses, they see very little movement, whether you choose blended or subdivided approach, primarily because we said earlier that the assumption was that the specialty businesses use 4 times the energy that a conventional product or a commodity product would consume. So I'm going to turn it over to Randy to round this out.
Fantastic. Thanks, Rebecca. Let's see how we did and how this apportionment approach could be useful in spurring investment in these kinds of technologies. So we saw that the change for the specialty is much more dramatic if you can distinguish the sources of energy and allocate them specifically towards the businesses that are willing to pay for that sort of thing. So it provides a lot more flexibility than you would have if you had to move an entire global integrated site in one direction. You can move bits and pieces of it as a way of jump-starting that transformation process. It enables smaller product families to justify this kind of investment, and because they can see a change actually show up in their product carbon footprint. It diminishes some of the costs to the commodity businesses, which they're always excited about. If the specialty business can absorb a greater proportion of this investment and do some kind of a cost sharing, that is a welcome change for the commodity businesses. And hopefully, this would be one project, and you would do a subsequent project and continue building on this because you've initially demonstrated the value. If you have the lower carbon footprint for specific products, that serves as a case study to help gain traction. And also, this is a case study. It is a way of thinking that has spread to other kinds of ideas that we're having at Eastman in terms of chemical recycling specifically. So if you start with the idea that, like in mechanical processing or mechanical recycling, you would have a dedicated facility for recycling. Well, if you shift that paradigm to a chemical recycling and demand a dedicated stream, you would have to build your plant all over again. And so building a new and separate plant would be expensive. It would have a lot of GHG emissions from that construction, and it would be slow. I don't think that it would be easy to justify that kind of investment. Whereas if you're able to do a blended approach in the chemicals that you're mixing, and then keep track of it, just like we're keeping track of the energy via the energy apportionment approach, or how energy might be kept track of for RECs on a utility scale, you can apply that same logic to keeping track of recycled material throughout your plant, even though it's physically getting mixed in different tanks. So that's just one example, but I think that it's a compelling one, and it illustrates how we keep going on this sustainability journey from a position, a dozen years ago, where you're thinking about sustainability as maybe a nice to have or just a mechanism for compliance. Then you start to measure these footprints and figure out ways to drive the footprint down, participating in great programs like the Energy Star program that help you internalize and figure out what your own emissions are. Then once you start driving down those emissions, you can reach out more to the value chain, get people excited outside of our gates, and engage in sustainable innovation. You need those initial sustainability stories in order to gain traction and credibility to be able to go outside and then hopefully build up to large-scale production changes like Eastman is doing with circular economy that is, pretty radically different from the way that a lot of these ideas were thought of a decade ago. So I think that it gives me a lot of reason for hope that this method is, one tool in the toolbox, but helps to jumpstart innovation and just different ways of including the manufacturing burden in how you think about the value of a product. So it's a stepping stone, right? It can't get you all the way, but being able to internalize that creates a good environment where you can have more institutional change. You have an increased awareness in the impact of your energy carriers, hopefully sparking future investment and renewed emphasis on sustainability. So, I think that this is it is in some sense a niche application of kind of an esoteric aspect of life cycle assessment, but at the same time, it's fun to think about the possibilities of how to leverage LCA to drive this kind of value creation and in creating more sustainability in the whole company. So again, huge thanks to Valentina and EarthShift for helping us write this article, and we're both very pleased to be able to share with you, and I invite any and all questions. You have our contact information too at the bottom, so if you are taking more time than an IM to respond to Holly, we're happy to reach out with you later. Thank you very much.
Thank you both, Randy and Rebecca. I do have some questions for you from our audience. The first is, why are the greenhouse gas emissions for solar larger than they are for natural gas?
I'll take this one. So the solar investment, it's due to cost. So we assumed the same capital investment. So $30 million goes a lot farther in a retrofit of a coal-powered powerhouse than what you can buy in solar panels. So you can get a lot more energy out of a retrofitted powerhouse than you can out of $30 million worth of solar panels. So it's more about the energy production. We didn't standardize on energy production, we standardized on cost.
Okay, thank you. Another question. Randy, Rebecca, I guess you can take turns answering this. Can you expand on how you got the attention of the company with what you're doing?
Sure. So there were a number of products that were interested in driving down their carbon footprints however they could through innovation and process improvement within our gates, and also trying to focus on the energy, or at least they knew that they needed to get to a lower carbon footprint in order to have sustainability as part of that value proposition. And so because we've, for a number of years, tried to spread the word that we have life cycle assessment capability within the company and that we have the ability to measure these carbon footprints, then the business areas that we're hearing from their customers that they needed this improved carbon footprint were able to come to us and brainstorm ways of reducing that carbon footprint. And many ideas are being investigated simultaneously, but one was to break out the energy carriers and allow that business to pay more so that they could have the lower carbon energy.
Yeah, and it was a really exciting meeting that Randy and I were in. That was kind of the pivotal point. We were sharing the LCA of one, or at least the carbon footprint of one of the products that trying to go to market with a sustainability story. And one of the executive leaders asked, has anyone ever bought a product on sustainability? And they said, well, I don't know a case where they have bought on sustainability, but I know they've deselected our material because it wasn't as sustainable. And that was a turning point, I think, for our company, where people started to realize that having a sustainable portfolio was important to win in the marketplace.
Absolutely. And since then, we've seen a lot more examples that now we can point to and say, yes, definitely, this is a material market driver, right? You can, it's part of the value proposition, and in certain areas, it's becoming table stakes to have an LCA, and not only that, but have better carbon footprint.
Cool. Very nice. But so another question is, doesn't this set up a situation in which you're picking winners and losers and arbitrarily advantaging some products, thus divorcing the true environmental impact from what you report?
It could, but we want to look at it as the base case is that this wouldn't get done. These activities wouldn't happen at all without being able to link to a business driver. And so the fact that the businesses that have a more material need for a lower carbon footprint can pay and vote with their dollar for these kinds of innovations, in some sense, yes, you could say that it's artificially distorting that, but it's no more of an artificial distortion than strictly saying that everything must always be blended and averaged together. So we feel like it's more of a way of making the impacts of manufacturing closer to what's top of mind for those business developers.
Right. So we just happen to be disadvantaged in being able to justify energy investments that benefit single products because our site is so large and so integrated, or several of our sites are so large and so integrated. However, if you had lots of little sites, you could do a $10 million project and it could reduce the carbon emissions for your entire site by 30% or something. But in our case, you could spend $30 million or $50 million and none of the life cycle assessments would move if you didn't do something like this. So if you want to be able to make those investments to justify them, because they generally do cost more, then you have to have a way to see the benefit in some of your products, at least.
That's a good point.
Can you elaborate on the impact that this has had on the way Eastman views the value of sustainability?
Sure. So over time, Eastman's transitioned from the way we would talk about sustainability as being exclusively tied to product performance and the more generic ways of talking about the value of a product, and that sustainability didn't really feature as a major part of these kinds of news articles. This is a snapshot that we've pulled up of a couple of the highlights of these news articles, seeing how the way that we're trying to position these products is much more focused on sustainability now than it was even just a couple of years ago. So once you're able to get that foothold and engage in applications where the stakeholders are aware of sustainability, it's just a feed-forward loop, right? It gets faster and faster, and now it seems like the carbon footprint is on the top of mind in far more applications and more industries than I would have been able to predict a few years ago.
Wonderful. Is this case study directly referring to a practice Eastman already has and in place?
Yes, it is. You can read the sustainability report, our latest one, and it talks about how we've retrofitted one of our coal power plants to a natural gas burning power plant to reduce the carbon emissions, and it was subdivided to benefit our biomaterials platforms, our cellulose esters products.
Very good. And does Eastman have plans to use this technique for other future programs?
If there's a good fit, absolutely. And you could imagine this going forward into true renewable energy investment, that the businesses are much more willing to support that kind of investment because they know, based on this energy apportionment approach, that they would be able to see that in their products. So I think the answer is hopefully, and we're going to continue to advocate for and drive that.
Very good. Did you have something to say, Rebecca? Sorry.
Well, it sparked a thought.
Please.
So one of the things that I think that we didn't directly say in this presentation is that doing this approach allows the decision maker for the energy investment to go down deeper.
If you can only make a large investment, then the decision makers have to be at the very top of the organization. But if you have the ability to see a change in the product carbon footprint at a lower level and apply a smaller investment to a business that is more narrow and serving one or family of markets, then that business can make these kinds of decisions with more autonomy. Is that kind of what you were saying, Rebecca?
Yes, that's what I was trying to say.
Yeah, you were breaking up, Rebecca. I think that's why he jumped in. And so then, do you think this framework would be applicable to other kinds of organizations as well?
Yes, though it is, as Rebecca mentioned earlier, the fact that Eastman has this large integrated site with on-site power production makes it a little bit unique. there are other companies that have a similar situation. And for those organizations or different processes, yes, this would absolutely be applicable. I think that more generically, if you're thinking about how RECs work, that RECs are a parallel, renewable energy credits are a parallel to this energy apportionment approach, just at a larger scale. So there are probably some intermediate scales that you could try to tease apart the different sources of energy, or maybe different manufacturing processes. If you have two manufacturing lines in parallel that have different performances, distinguishing their different footprints could be useful, all sorts of different ways.
Okay. Well, I've reached the end of my questions here. I think it's been a very informative webinar. Thank you both so much. And I'd just like to let our audience know that next month we'll be redoing the Brown Bag webinar with Valentina on reconciling values and facts in comparative LCA. So I will close this webinar now and thank everybody for their participation, and especially Randy and Rebecca. Thank you. Keep up the good work. Bye now.
Awesome. Thank you so much.